Hello class, in this video we're going to be looking at the Pearson's correlation coefficient. The learning intention of this video is for us to develop an understanding of Pearson's correlation coefficient and for us to learn how the correlation coefficient is used so we can identify the strength of the correlation. Let's quickly review how do we examine the correlation of two variables. When we're commenting on the strength of the correlation, we could either describe it being weak, moderate, or strong, and the strength of the correlation can be found by two ways. The first method involves examining the density and location of all the points and how close it is to the line of best fit. But remember, as I said in the previous lesson, this is a relatively subjective measure, and in some circumstances, it might be hard to accurately identify whether it is strong, moderate, or weak. Alternatively, another way to find out what is the strength of the correlation is by calculating the Pearson's correlation coefficient. In today's lesson, we're only going to be looking at what the Pearson's correlation coefficient is, and in the next lesson, we'll look at how do we actually calculate this actual value. So Pearson's correlation coefficient, which is represented by the letter R, measures the strength of a linear association, meaning a linear relationship, and it scores it with a numerical value between -1 and +1. So at the moment, I've got a nice graphical illustration which shows all the values from -1 to +1. And as you may know, any values that's on the positive side will therefore have a positive association. Any values with a negative symbol will therefore have a negative association. Another key feature that I need you to recognize is that any values that's more closer to -1 or +1, then it's going to have a strong relationship. Whereas as you progressively get closer to 0, then you're going to gradually have a more weaker correlation. In this particular diagram down below, this kind of nicely summarizes where you could find and locate a strong negative, a moderate negative, and all these other different types of strengths. However, I rather you refer to the following chart over here when you're identifying and diagnosing what is the strength for that particular correlation. The reason why I prefer referring to this particular chart compared to the illustration beforehand is because this will allow me to accurately identify what is the strength of the correlation if it relies on values that are kind of in between the two different types of strengths. Okay, so that's the reason why I prefer referring to this chart compared to the scale from beforehand. This over here is a nice illustration that shows you that as the correlation between two variables are more stronger, then the points are going to be found more closer to one another and more close to the line of best fit or to the trend line. However, you may be wondering why the values -1 and +1 are not included in this particular table over here. When we've got examples where you do have a -1 or a +1 as your value for the Pearson's correlation coefficient, this would therefore indicate that you've got a perfect positive or perfect negative correlation. So you might want to add these two parts into your particular chart when you're copying down the notes. In order for us to use Pearson's correlation coefficient, there are three key assumptions that we need to keep in mind of. Firstly, we can only use Pearson's correlation coefficient when we're trying to find out what is the strength between two numerical variables, okay? So this means that we cannot use it to compare the correlation between categorical data. Another thing that you need to keep in mind of is that the association between these variables must be linear. We can't use this when you've got a non-linear relationship as shown in this particular example over here. And the last consideration is that you should generally not have any outliers at all in your scatter plot. When you do have an outlier, as you can see in this particular example over here, this is not going to accurately tell us what is the strength of the correlation. What I'm going to do now is I'm going to show you a series of questions, and hopefully using your notes, you should be able to answer them correctly. In the first question, I want you to identify what is the strength for the following R value. If you answer this question correctly, then it's going to be a positive, and because this value is more closer to 1, it's going to indicate a strong relationship. So therefore, B is going to be the correct answer. Have a go with the next question. Since it has a negative sign, I know that's going to be a negative relationship, and because this value lies in between 0.5 and 0.75, I know that it's going to be moderate. So therefore, the correct answer is going to be C, negative and moderate. In the next question, identify what is the appropriate scatter plot that matches the R value of -0.97. In this particular question, because the value is more closer to -1, I know that it's going to be a strong negative correlation. So therefore, this is going to match up with scatter plot B. Similarly, do the exact same thing for an R value equal to +0.02. In this particular question, because this value is a lot more closer to 0, I know that this is going to have no correlation whatsoever. As a result, the answer is going to be D. For the next question, I want you to predict what R value could this scatter plot have. In this scatter plot, we can see that it's got a positive correlation, so therefore it's either going to be B or D, but because this has a more stronger correlation, therefore I'm going to say D as my answer. Similarly, do the exact same thing for this particular question. In this particular example, we can see that there's a very subtle negative direction over here, so therefore I'm going to say it's either going to be A or C. However, we can see that the points are really scattered away from one another, so therefore I'm going to say this is extremely weak, so therefore A is probably going to be the best answer for this question. The last thing that I'd like to talk about in this video is about correlation versus causation or causality. And the takeaway message that I want you guys to understand is that a strong correlation does not imply that there's a causation. In other words, a strong correlation does not imply that the explanatory variable will have an effect on the response variable. Let me use an example to demonstrate what I mean by this. In the example down below, it says that there is a strong positive correlation between bad smells and disease. Does this mean that we can conclude that bad smells cause diseases? Even though it may be likely that bad smells may cause diseases, we are not 100% certain this is the case. As a result, we should avoid statements that suggest there is a 100% certainty that variable X does cause variable Y to occur. In this example, the high correlation is not because bad smell causes diseases, but because there is a common response or a common variable that causes both to occur. So if you look at the diagram down below, you can see that germs causes both bad smells as well as diseases. And this is the correlation or the link between bad smells and diseases. It's because we didn't have the full picture beforehand that one may assume that bad smells cause diseases, but this is actually not the case at all. So the take-home message is that you want to consider other variables or other factors that may affect or explain the causation. So I would like to reiterate that the presence of germs is the common response or the common variable that causes both bad smell as well as diseases. Let's look at another example. In this example, it reads, there's a high correlation between smoking rate and heart rate. Can we conclude that smoking causes heart disease? The answer to this is going to be no, because there are other factors or other variables that could also contribute to heart disease. For instance, another factor could be poor diet, okay? So poor diet could also cause and explain why one may have a higher risk to heart disease. These other variables, such as poor diet as well as a lack of exercise, are referred to as confounding variables. So these are variables that can be mixed up or masked by the original variable that we're investigating, which in this case is smoking rate, okay? So there's no way that we're entirely sure that smoking rate does occur or result in a greater likelihood of heart disease if there's also other variables that may also explain the condition, such as poor diet and lack of exercise. Let's look at one more example. In the final example, it reads, there's a strong correlation between cheese consumption and the number of people who died becoming tangled in their bed sheets. Can we conclude that eating cheese causes one to sleep so restlessly that it increases the likelihood of death by bedsheet? In this example, there appears to be a ridiculous correlation between the two variables, as there is no association between the two variables in real life. As a result, we explain that the high correlation between the high cheese consumption and high death is due to coincidence, not causation. By now, you should understand what is the difference between high correlation and causation, and you should be avoiding statements that suggest that there is a causation or a high probability that it will occur. Always consider that there are alternative explanations and whether it is due to a common response, a confounding variable, or due to coincidence. What I'd like you to do now is I'd like you to now please answer questions from exercise 7D to get further practice. This is the end of the video. Thank you for watching, and I'll see you guys again in the next one. Bye.